next video is going to be reviewing the normal distribution problems that we faced on that Quizizz. First of all, number one, between what two standard deviations of a normal distribution contain 68% of the data? Now, this problem goes back to this normal curve that I just kind of sketched out. I didn't include the 99.7%, which would have been from -3 to +3 standard deviations. But the empirical rule basically states that, well, if you have the middle 68% of the data, then you are between -1 and +1 standard deviations away from the mean. Going back to this problem, you can see that the answer should have been 1 below and 1 above. It is, again, according to the empirical rule. If you really wanted to see it on the calculator, that's one thing you could do, I guess, where you go -1 to +1 standard deviations, which again is approximately 68% of the data. Number two, which best describes the shaded part of this normal distribution graph? Now, again, if you notice the mean right in the middle, mu is equal to 0, with +1, +1, +1 standard deviations, -1, -1, -1, this has a mu of 0 and a sigma of 1. So if you did go to your normal CDF, you could type in a mu of 0 and a sigma of 1. But that's not what this question is asking. What this question is asking is which statement best describes the shaded part of the normal distribution. All data is below 1. All data that is 1 or more standard deviations above the mean. All data that is between 1 and 3. All data that is above the mean. This statement here, all data that is below 1, that doesn't really mean much considering that they're not really describing what 1 is. All data that is between 1 and 3, I mean, if you said standard deviations, that's one thing, but it does clearly go beyond 3 standard deviations. All data that is above the mean. Now, anything that has a standard, or anything that has a z-score greater than 0 would be above the mean. The answer has to be all data that is 1 or more standard deviations above the mean. And you can see that right there with that green check mark. Number 3, the normal curve is symmetrical about the mean. Now, this is one of your just definitions, logical statements here. Yes, it is. The normal curve is supposed to be symmetrical with the mean right in the middle. You can see it's true. Number 4, now we're getting into some details. The weights of adult male beagles are normally distributed with a mean of 25 pounds and a standard deviation of 3 pounds. Now I'm going to write down some of this information. Mu is equal to 25, sigma is equal to 3. A beagle is randomly selected. Find the probability that the beagle's weight is between 23 and 26 pounds. Now I'm not going to draw this whole thing out. In terms, well, for every problem, that is. I'm not going to draw this out for every single problem, but I am going to draw this out for this particular problem. For this particular problem, there's my terrible normal curve with my mu right in the middle, and the standard deviation's 3, which makes this a 28, 31, 34, etc. Down here, it would make it 22, 19, 16. And what they're really asking for is, okay, well, what percent of the data is between, let's say, 23, which is right there, and 26, which is right there. I'm going to draw this in because I'm not going to do this for every problem. But they really want to know what is the area of that shaded region. Make that a little nicer. Now, because they're asking for a percentage, and you can see that in the choices that they give you, they're giving you decimals, which are percentages. The way that we would do this, if you had a typical TI-83 calculator, is with a lower limit, an upper limit, a mean, and a standard deviation. On your Chromebook calculators, obviously they give you the interface where you could type in lower, upper, mu, and sigma, but that is the order in which you would type it in. Just to take a look as to what that would be, 23, 26, 25, 3 gives you approximately 37.8%, but 0.378 is another acceptable way of writing that answer, which you can see the decimal right there. Number 5. Now, number 5, very similar problem. You can see that right there. The only difference between the two problems are the limits, because now this problem is saying, okay, everything is the same. What is the probability that the beagle's weight is more than 29 pounds? Now, clearly, they even kept the choices the same. More than 29 pounds would be, again, I'm not going to fill this in all the way, but it would be about here or more. You know what? I'll do it anyway. Here or more. All the way out. For that problem, everything stays the same except for your limits. Because it's 29 or more, you would type in 29, comma, some positive big number, but you would keep the mean and the standard deviation exactly the same. Now, it doesn't really matter what big number you end up typing in as long as it's just some big number. I just typed in a 1 with a bunch of zeros. But I got to keep the mean and the standard deviation the same. Approximately 9.12%, which, if you look at your choices, clearly it's got to be that one right there. Let's look at number 6. Number 6, the mean temperature in Glen Falls for the month of February is 23 degrees with a standard deviation of 4.2. What is the z-score? I'm going to stop right there. What is the z-score? Now, this is a different type of question. They're specifically asking, what is the z-score? Now, in terms of calculating what is the z-score, I'm just writing out this information here. The data point minus the average divided by standard deviation. That is how one calculates a z-score. A z-score tells you whether or not you are better or worse than the mean. Positive meaning you're above average, negative meaning you're below average. The mean temperature in Glen Falls for the month of February is 23 degrees. So I'm just going to write out this information, and then I'm going to jump back to the screen with a standard deviation of 4.2. What is the z-score for a temperature of 17? Now, what that means is this. The average is 23. That's just average in whatever, for the month of February, I believe. Yes, for the month of February. Standard deviation is 4.2, meaning on average, each day deviates by about 4.2 degrees. On one particular day, it was 17 degrees, meaning it was below average. You want to calculate the z-score for this. Well, again, typing it in correctly is a very important job. The way that I typically type it in is I put parentheses around the top of that fraction. Negative z-score. A negative z-score of 1.43, I'm going to round it to, meaning it's below average. It's about 1.43 standard deviations below average. And you can clearly see right there, negative 1.43. Click. Number 7. Pat and Chris both took a spatial abilities test. Mean, standard deviation, we'll talk about that. Pat scored a 76. Chris scored a 94. What percent of individuals would score between Pat and Chris? Now, because they're asking what percent of individuals would score between Pat and Chris, I'm definitely going to be dealing with a normal CDF. Now, when I'm thinking about this problem, normal CDF, they want to know between Pat and Chris, Pat scored a 76, Chris scored a 94, with an average of 80 and a standard deviation of 8. Look what I wrote out here. Lower limit, upper limit, Pat and Chris. Mean is 80. Standard deviation is 8. That would be the order in which you type that stuff in. Now, again, your interface is going to be different than my interface on your calculator, but you would do lower, upper, mu, standard deviation. You can see how it's typed in right there. about 65.1%, which if you, well, 65.1%, right on the dot. Keep in mind that if they give it to you as a percentage, you give your answer as a percentage. But obviously, most of the time, the percentages are going to be written in decimal form. Number 8. The distances male long jumpers for state college jump are approximately normal with a mean of 263 and a standard deviation of 14. Suppose a male long jumper ranked in the 75th percentile. Now, all of a sudden, we have a different type of problem on our hands. Now, I bring back this normal curve to bring you to kind of talk about this. I'm going to put my pen right in the middle. Right now, my pen is sitting at the 50th percentile, meaning 50% of the data points lie below the pen and 50% lie above the pen. Now, I'm going to move my pen right here. Right now, my pen is sitting actually at the 84th percentile, meaning 84% of data points fall below the pen and 16% of data points lie above the pen. I could go right about here. Now this, if you want to take a moment to kind of think about it, this is the 16th percentile. This was the 16th. This right here where I'm pointing is the 84th. But my pen is at the 16th percentile, meaning 16% of my data points fall below and 84% fall above. Depending on where you are, it might be a different percentile. But if you're dealing with percentiles, you better believe that you are going to be dealing with inverse norm. I'm going to draw a little picture for this one. Well, let me go back here first. I'm going to draw a little picture for this one, just to kind of give you the visual of the whole thing. Let's just pretend that this right here is the 74th percentile. The question says, suppose, 75th, I apologize. 75th percentile, that's what they wanted. Suppose a male long jumper ranked in the 75th percentile. How long was his jump? Now, you could do one of a few things here. You could figure out the whole z-score situation and kind of go from there, but in reality, what you want is inverse norm. Because what inverse norm is going to do, depending on what you type in, it's going to do one of two things. And I'm going to show you both ways, actually, how to do this. One way of dealing with the problem is this. Inverse norm 0.75 with the average and standard deviation typed in. Now, for your interface on the calculator, you would have an option for left, center, or right. You would do left. Keep it on left. Because if you did left, it would mean that 75% of the data lies to the left of you. If you did inverse norm 0.75, 263, 14, as I have typed right here, you can see that it spits out a data point of 272 and change, 272.44, which clearly is the answer that they're looking for. Another way of thinking about the problem. Now look at that. Inverse norm 0.67. Now that number, that decimal number, actually is the z-score at that percentile. It's about 0.67 standard deviations above the mean. I'm just showing you an alternate way to kind of get this thing done. But if you wanted to figure this out, you could actually solve this problem. And this problem would get you the same answer. It's much, much, much easier to do inverse norm. But I'm just showing you how the two formulas relate to one another. If I were to actually solve this correctly, now mind you, the answer is 272.44. But if I were to solve this correctly, using my algebraic skills, you can see that I get the exact same answer, 272.44. Again, showing that there. Number 9. In a factory, The weight of concrete poured into a mold by a machine follows a normal distribution with a mean of 1150 and a standard deviation of 22. Approximately 95% of molds filled by the machine will hold weights in what interval? Now, I want you to think about 95%. 95%. 95%. That is according to the empirical rule. That is the 68, 95, 99.7 rule. Meaning that 95% of the data will fall between -2 and +2 standard deviations away from the mean. So 1150 is the average, 22 is the standard deviation. 1150 plus 22, twice gives you 1194. Subtracting it twice gives you 1106. You can see it right there, 1106 to 1194. There wasn't anything crazy that had to be done other than recognizing the empirical rule. For that, over number 10. Find the value for this. Now, this number is a z-score, 2.46. Now, I'm going to go back to this screen right here. A 2.46 z-score would be about right there where my pen is pointing. Let me do that. Right about there where my pen is pointing, 2.46. And what this question is saying is, what is the probability of having a z-score at 2.46 or greater than 2.46, meaning everything's shaded to the right of where my pen was pointing. Now, if that is the case, in my calculator, all I have to do is type in 2.46 comma big number. In your calculator, you would just have to make sure that you keep the mean at 0 and the standard deviation at 1. And as long as you do 2.46 for your lower, some giant number for your upper, 0 for your mu, 1 for your sigma, it would spit out that correct answer. Now, this is approximately 0.7%. It rounds up. 00695. Yep, there it is, 00695. Yep, it is the answer we're looking for. Just remember, if it ever says Z, it's referring to it being a z-score, meaning you just need to have it as your mu and standard deviation. Let me go back here, actually. Comma 0, comma 1. And you can see it gets you the exact same answer. Number 11, same exact problem, except now they want a z-score less than 0.39, or I'm sorry, negative 0.39. So same exact problem. So let me do this again. Because I'm going less than negative 0.39, I can do my lower limit at some big negative number, negative 100,000 or whatever the heck that is, comma, negative 0.39 as my upper. Negative 0.39, yeah. So which means on my normal curve, I'd be about here, negative 0.39, or less. So my lower limit would be way over there, and my upper limit would be negative 0.39. Oh, show you right here. Here it is. Chapow. 0.348, which 0.348. I would say 0.349 was a bit close, but it wasn't exactly the number I was looking for. It was this one. Number 12. Now they give you a mu and standard deviation. Now they give you the average. So since they give it to you, you have to think about it in terms of a data point. They want the data point 400 or greater. Now, I'm not going to write this in on here, but it would basically be, what was it, 350? 350 would be right in the middle. And since my sigma is 20, it would go 350, 370, yeah, there it is, 370, 390, etc., all the way up. They want 400 or greater. Meaning, I would do 400, comma, some big number, comma, was it 350 and 20? 350 and 20 for my mu and my sigma. 0.0062. There it is. 0062. 13. The scoring of modern IQ is such that the intelligent quotients IQ have a normal distribution of mu equal 100 and sigma equal 15. Mensa International is a nonprofit organization that accepts only people within the top 2%. So hold on a tick. The top 2%. I'm going to draw something real quick before I do anything else. The top 2%. The top 2%. Now, if that's the top 2%, you really have to think about what percentile you're at. You're actually at the 98th percentile. You're actually at the 98th percentile. So if you're at the 98th percentile with an average of 100 and a standard deviation of 15, look what I'm typing in right there. The 98th percentile with 100 as my average and 15 as my standard deviation. Now, on your calculators, if you did left, this is exactly what you would type in. If you did it to the right, you could do 0.02, but I'm trying to get you into the habit of not changing it. Which means if you were in the top 2%, you would have an IQ of 130.8 or greater. So 130.75 is what they got. Yeah, they probably rounded it a bit differently than I did. Mine's correct. Mine's more correct than theirs is. Number 14. If the shaded area under the curve is 0.85, what is the other missing portion? Well, 0.85 is 85%. The missing portion, you're missing 15%. That's just literally what it comes down to. Next. Find the area under the shaded region. You could either do the empirical rule here, or you could literally just do something like this. Now, mind you, because 0 is my mean, and it's going up by 1, 2, 3, and -1, -2, -3, that's changing by the standard deviations. So, since it's changing by the standard deviations, you could have your mu at 0 and your standard deviation at 1. And because they're doing 1 or less, you could do something like this. 1 or less, my mu at 0 and my sigma at 1. You actually don't need that second 0 or 1 there. I'll show you how you can just get rid of it. In your calculator, you would have to put in the 0 and the 1, obviously. But it's about 84% and change, which you can see right there, 0.8413. There it is. Number 16, calculate the z-score of your value if the mean is 75, your score is 90, and the standard deviation is 4.5. So for this problem, they are asking for you to calculate a z-score. So let's see what this one, I'm going to write down some information for this. The mean is 75, your score is 90, and the standard deviation is 4.5. So this is the information that they have given you. Calculating a z-score would be the data point minus the mean divided by the standard deviation, which in this case, again, if you type it in correctly, would be 90 minus 75 divided by 4.5, which is approximately 3.33. Of course, there's a little bit of rounding there, but you can see they only gave you two options, 3.33 being the correct one. Given that your score was above average, your z-score, of course, should be a positive number. Number 17. Number 17, if the value we are looking for is smaller than the mean, this goes into exactly what I just talked about. If the value we're looking for is below the mean, less than the mean, below average, the z-value is definitely going to be negative, as you can see there. If you are above average, you're positive. If you are right on average, your z-score is actually 0. Number 18. Well, there you go. If it's the same as the mean, the z-score should be 0. And there it is. Number 19. which gray area shows a probability closer to 0.5. Now, if you're going to have a probability closer to 0.5, then you should have a gray area that encompasses roughly half of the normal curve. Now, I'm going to just show you a couple options here in terms of what the answer could look like, but I know this is not any of the choices. If you're going to be dealing with half, then it's going to be the mean shaded all the way down. Now, that's approximately 50% of the graph shaded in. According to what we did with the empirical rule stated that if you went one standard deviation out, that would encompass 68% of the graph. That would be the empirical rule according to the 68, 95, and 99.7 rule. Now, 68%, of course, is greater than 50%, so let's see which one is slightly smaller than that shaded area. I'm looking at that. It looks like this one right here, where my mouse is, would be approximately 50%. Let's see if they actually did that. Yep, yes it is. Because again, if I shaded in this much from one standard deviation down to negative one standard deviation, it would be 68% of the data. A little bit less than that would be 50%, or the closest to 50% out of all of these. Number 20, if you had to guess the probability of the gray area, which would you choose? Now, I'm going to bring up another piece of paper right here, which again shows that same normal curve that we've been dealing with this entire time. Which does the entirety of the 68, 95, 99.7 rule. There's 68% of the data. There's 95% of the data. Now keep in mind, if this is 95% of the data, that means from these two lines out would encompass 5% split evenly, about 2.5%, about 2.5%. I'm looking at the choices that they gave me. It looks like what's shaded in is closest to 2.5%, which would be, well, the smallest right here is 0.2, which is actually 20%. So maybe 2.5% would be a little bit farther down. I just noticed now they have little dash marks there. Yeah. So that actually would be 2.5%. The closest would be 0.2. Yep, it's the closest, if I had to guess. But again, it would really be 0.025. Number 21, what is the total area under the standard normal curve? Well, again, I've been talking about all of these percentages, 68%, 95%, if you go out a certain number of standard deviations. If you went out all the way to the left and all the way to the right, that would encompass 100%. But the answer is not 100, because this number is not written as a percentage. 100% would be equal to 1 whole, which is why that is the answer. Number 22. The data is normally distributed. What percent of the data is in the shaded region? Again, this is the empirical rule. -2 to +2 standard deviations away from the mean. If I were to do this on the calculator, normal CDF, -2, +2, it wouldn't give me exactly 95%. It would give me something that's approximate to 95%, as you can see there. But that is why this answer is indeed 95%. Number 23. Given a mean of 75 and a standard deviation of 7, what percentage of scores are between 75 and 82? Again, this is one of those normal CDF problems that you could do, although you could do an empirical rule here. I'm going to show you how you can do it both ways. What I'm typing into my calculator now, which I'm going to flip over, are the limits of 75 and 82 with a mean of 75 and a standard deviation of 7. And you can see that in that order: lower, upper, mean, standard deviation, which gives you approximately 34%. Now, if I were to actually label this graph with a mean of 75 going up to 82 with the standard deviation of +7, of course, that would just be this region being shaded in, which is approximately half of the 68% that we named in the empirical rule, which 68 divided by 2 is 34, which is why this is approximately 34%. Number 24, find the z-score for 48 given a mean of 50 and a standard deviation of 5. Now, right off the bat, 48 is below average, which means the z-score should be negative. So which narrows it down to either one of these. 48 with standard deviation of 5. 48 is within one standard deviation of that mean. Just by process of elimination, the answer should be negative 0.4, but let's see what it actually calculates out to be. If I were to do this calculation, data point minus the mean divided by the standard deviation, as you can see right here, that would be negative 2 over 5, which is negative 0.4. That would be my z-score, which if I click this, there it is. Okay, number 25. Find the z-score for 75 given a mean of 60 and a standard deviation of 6. So again, above average. 75 is above average, which means it should be positive. It's definitely not within one standard deviation. It's actually over 2 standard deviations away. Standard deviation is 6. So if you went to 66 and then 72, 72 would be 2 standard deviations above. 75 is more than that. It's got to be 2.5. And you could do that exact same calculation like we talked about. 75 minus 60, which is 15, divided by 6, should give you 2.5 right on the dot. And it does. Number 26, the last question. IQ tests have a mean of 100 and a standard deviation of 16. Einstein's IQ was 160. What was the z-score? Well, clearly it was way above average. It was 60 IQ points above average, but how many standard deviations above? Well, just writing that thing out on paper, his IQ was 160 minus 100 divided by 16 should be 60 divided by 16, as you can see right here at the bottom of my page. 60 divided by 16 gives you exactly 3.75, which is clearly the answer here. Now, again, in terms of standard deviations, anything past 2 standard deviations away from the mean, either positive 2 or negative 2, is considered unusual. Anything beyond 3 is extraordinary. But that was the review of the quizzes that we did in class.